You're listening to The Machine, a podcast from Waterford Institute of Technology, kind of unofficial. My name is Rob O'Connor and I'm a lecturer in the Department of Computing and Mathematics. I'm joined on the podcast today by Brenda Mullally and Siobhan Drohan, both lecturers from the department, and Siobhan we've heard on our previous episodes. So Brenda, you're very welcome along for the first time. We have set up a podcast Twitter account specifically for The Machine. It's very simply at machine_podcast. And if you want to get in touch with us, that's the best way to do it. We're also available on all the major podcasting platforms. Since the last episode, we're up on Spotify. We're also available on iTunes, Stitcher, Overcast, etc., etc. And if you're listening to this and we're not on a platform that you use or you would like to use, please let us know so that I can get it sorted. So just send a tweet to @machine podcast. Also, if you'd like to leave us a positive review on whatever platform you use, that'd be great. It would help us with the rankings. Algorithms push higher rated podcasts to the forefront. I'm not quite sure how this works, but it's all data, ones and zeros, flying around in the world as part of this interconnected system that we call the cloud or the internet. And that leads us on to today's topic for discussion and explanation: data and big data. Brenda.
Yes.
What is data?
Data, I suppose you can think of it in terms of facts and figures. So small pieces of data, individual little things like the temperature today, your age, the time your bus is due to arrive, things like that. Maybe the balance in your bank account. So small pieces of data, facts, figures. That's what data is. And there's lots and lots of pieces of data that is stored about you, about how you get to work, if you use apps on your phone and your smartwatch, how you sleep. So small bits of data are generated all day, every day.
What's the difference between data and information? Is there a difference?
There is. Classic question. Information is processed data. So when we make it more usable, when we present it, when we interpret. So you piece together lots of bits of data. It may be the number of times the bus is late. It could be how many times you're gone into your overdraft and your bank balance. You're piecing together bits of data, you're summarising it and interpreting it and making sense of it. And so then it becomes information that is more usable, far more relevant to you, and be able to ask questions of it than just having a piece of data like my age.
So would the example I would often use in class, and bear in mind I'm not a data person, I don't really fully understand it, but if I said 31102018, that's a piece of data.
Yes.
But if I said Halloween 2018 is on 31102018, 2018, 31st of the 10th, 2018. That's now a piece of information. Is that correct?
Yes, and I suppose you could even contextualise it more and say what day of the week that was on,
yes,
and what the weather was like on that day. And so you piece together many different parts of your data and provide it in an informative way. So
data is raw facts and figures.
Yes.
Information is that data with some context.
Yes. Some processing. It could be that you're adding lots of figures together or getting an average, or that you're describing a person with many pieces of data that's stored about you. So for me, my age, my height, maybe my weight, and other piece of information about Brenda Mullally. And so that creates context. It gives you more understanding about Brenda Mullally as opposed to just looking at a number.
Siobhan, so
yes.
you're a programmer.
I am.
Yep. You're, if you could put you in one box, not that I'm trying to put you in a box.
That's my main area. Yep.
Is that what data means to you?
So exactly it is. And what we would do is then write programs around it to process all of that data. So it's exactly what data is for us. But then we would store that data in different types of locations. And then you'd move on to how do you store the data Is it structured or unstructured and stuff like that.
So when you're talking about locations, you're not talking about physical locations. We're not talking about, like, if you're listening to this and you might recall things about data centers and Apple in Galway and Athenry, or Amazon in Wicklow or somewhere like that.
Yep.
That's not what you're talking about. You're talking
Nope.
about a physical, a logical location that might be on a computer.
Exactly, yeah. Because you can store data absolutely anywhere within your computer. You could store it in a Word document, an Excel spreadsheet, or you could store it in a database. And there's different types of things that you can do. Like if you want to do any sort of, as Brenda was saying, make information out of data, it's going to be quite tedious doing it through things like Word documents, because it's not really structured really well. And it takes a lot of manual handling on that. Whereas if you store data in what we call databases, it's a natural place where you can store it, and you'd have a database on your computer or you'd use one in the cloud. And that's the natural place to store data.
So what is a database?
So basically a database is somewhere where you can store, you can save your data, you can do operations on it. So there's facilities provided within the database for you to be able to, as Brenda was saying, figure out how many times did you get that bus yesterday, or how many times did you kind of walk up a set of stairs. So the database will help you to gather and process that information. So a database is used to process the information that you have stored within it.
And Brenda, a database is an example of what we call structured data.
Yes.
So maybe you might be able to expand on that.
Yeah. So data doesn't just come in one form. It can be numbers, it can be images, sound, it can be video. And so we have to store it in different ways. We have to be able to get access to it and manipulate it in different ways. So there's different types of storages. And databases traditionally store structured data. And structured data is data that is consistent, and we know what it contains. So we know that it's a number and it's going to be no bigger than 9 digits long. Things like that, or we know that it is a date. And so structured databases are the very sort of traditional ones that we are familiar with in terms of business. Finance data is stored in structured databases, production data, all of that kind of transactions that we do. Every time we go to the bank, every time we buy something in Tesco or Lidl, those pieces of data are stored in relational databases predominantly.
So this would be kind of like a table. So if I can imagine a table with boxes, so like something that might look like an Excel spreadsheet, but it isn't an Excel spreadsheet. And you would have rows and columns, and on, let's say, an item that might be for sale in a supermarket, that might have a column that is the supplier who supplies this. It might have a price, a unit price. That might be another column. It might have a quantity, which is a number of items that are currently on the shelf. It might have an expiration date, a whole bunch of things associated with that item, but they're in separate formats so that they're easily searchable, and rather than just in the unstructured format, like what Siobhan was talking about earlier with the Word document, where it's just a piece of text all over the place, and it might be hard for a computer to infer meaning from a date in a piece of text because it mightn't be structured. Whereas if it's in a field that is expiration date, well, it knows that this date is the expiration date because that's the name of the field. Is that
exactly
roughly right?
Yes, yeah. I suppose with our structured data, we want structure on it because we want to be able to run reports, do analysis to find out how much did we sell, when did we sell, what did we sell, who bought what, when. So in order to do that, you must place structure on it, and you must store the data in a particular place. And each piece of, or each row in that table is related to other rows and other pieces of data. So you know which customer bought which product, when they bought it, and in which store. Whereas if you think of unstructured data, a lot of unstructured data is text. So whether it's a chat on WhatsApp or Facebook Messenger, or whether it's on a blog, commentary, it may be the use of a website, how people access a site, how long they spend on a particular page, what's the next page they move to. a lot of that kind of data is unstructured, and we're not sure how much text there's going to be. Is it going to be an image? Is there going to be some commentary? Is there going to be a video? And so we can't structure it in the same way. And there's a huge volume of that data being generated all of the time. It's a little unknown. And so that's much more of the unstructured type of data.
In one of the earlier podcasts, we were talking about programming, and we used a kind of a cooking analogy to talk about scale, about you might cook something. But then when we talk about scalability in terms of DevOps, we were talking about, well, it's not cooking for 4 people, it's cooking for 40 people or 400 people. And I'm kind of thinking about another cooking analogy here, in that, because you're talking about to figure out how much this was or how much we sold or whatever. So that's a kind of an operation, which sounds to me like it was something that would be programmed. So the program would be the act of finding out, answering some question, X, Y, or Z. And the data is what feeds into the program. So to use our cooking analogy, the program is the set of instructions that you would follow, and the data is the ingredients.
Sure.
Would that be?
Yes, yeah. Yes. But and I suppose depending on what the output of your recipe is to be, if it's to be a very complicated, fancy cake, 4-tier and whatever else,
Not in my kitchen.
you need to ensure that you have the right ingredients.
Yes.
So you can't produce something at the end if you're missing the flour.
Yes.
So you have to ensure that you have all the correct ingredients. And then obviously the processing can be quite complex. And you only get the best output if you have the best input. And so the best ingredients, the best access to data that's accurate, up to date, consistent is very, very important in data.
I think we're going to keep this cooking analogy going over the podcast because it's quite a good one.
And it's coming up to lunchtime, so you're hungry.
Yeah. Right. So we've talked about what a database is. We've looked at structured versus unstructured data. We've actually that's leading us then on to a term that I'm seeing increasingly, which 2 terms: data science and big data. Now, data science, I'm not quite sure. Everything gets science put after it these days, right? Political science, all sorts of stuff. I don't know what table science. Data science, to my limited understanding, it seems to be a kind of an intersection point between programming, mathematics, statistics, and maybe another form of like some sort of like analytical science. Is that correct? Wrong?
I suppose it depends on who you speak to.
Okay.
Like so many terms that are used in computing, they start off as buzzwords and then they're adopted.
Yes.
And so data science, originally I suppose it first came as a data scientist, was a popular name given to those people that were very much from statistical background, I would consider.
Yes.
And they were experts in analysis of data and discovering patterns and predicting things. They were data scientists. But now that form of analysing data has become more accessible.
Yes.
The skill base has changed. And so you don't need to be a data scientist in order to conduct that type of analysis. And so now this data science covers a broader type of person, I suppose, in terms of skills. And you have so many tools that you can use that support that process. You don't have to necessarily have such a strong mathematical background or programming background.
Okay.
And the role of the analyst has become greater, and the skill set of analysts have been adopted within, I suppose, many positions in organizations, that more and more people have access to do analysis, and so that's part of their job now.
So to Siobhan, because I'm going to give you the other buzzword that we're hearing a lot,
Big
which
data.
is big data. Now, I'm not quite sure what big data means, but the very nature of it implies that because you see we're in the world of big data, that this implies that we were previously in a world of small data.
Exactly.
What does that mean? What does big data mean?
Well, I suppose if we first look at the context that you're talking about there, of where we were in a world where there wasn't as much data years ago and now there is, like if we gathered basically all the information we have from the beginning of time until the year 2000, so from the beginning of time to the year 2000, all the information that existed then, it would be less than the data we create now in a minute. So if you think about how much data we're creating now in a minute is basically all the data from the beginning of time up to the year 2000. That's where big data is starting to come in. You can see that there's a huge amount of data being created. If you think about your own online presence or your own presence at the moment, about the amount of data that's being created, from your smartphone, from your email, from every single, your Fitbit tracker, you're creating a colossal amount of data at the moment. And so big data has basically emerged as a buzzword in recent years. So basically what it is it can provide a window to the world where customers, for business basically, where customers have never previously imagined. So they have to look at all of this data first. Where do they look at this? What platforms do they go to? Is it social media? Is it all their customer-based information that they've stored in the computer? What's relevant? How do they access it? And how do they turn all of that information into knowledge is kind of the context around big data. And basically, there's a colossal amount of data now out there. And it's, as we were talking earlier, it's both structured and it's also unstructured. And what businesses are doing now is they're analysing it all for insight. So they want to use it to make better decisions, to predict customer behaviour, loads of different things like making strategic business moves, better medical treatments and so on. So they're using their data skills to analyse this for a better product for everybody.
While I was doing a bit of research for this podcast, I came across, I was listening to a couple of other podcasts and was reading some articles, blogs and things like that. And I did read a good one where I can't remember where it was now, so apologies for not attributing to the person. They were explaining the difference between kind of what the difference between big data and the previous incarnation of data science. In that talking about data sets, and a data set could be 5 years worth of weather reports for Wexford, okay, in the southeast of Ireland. Or it could be 5 years worth of data on brain scans and blood reports for patients in a clinic or a hospital. But when you put them together, that can be big data because a data scientist might be able to infer some insight or spot some pattern between the effect of sunshine on multiple sclerosis patients in the southeast. Is that... No, Brenda, you're disagreeing.
I'm nodding.
No, I'm not getting into the ethics of it, right? But go on.
Big data is a misnomer, like so many of the terms that are used in computing. It's not just about the size, really. Yes.
Why are you saying size doesn't matter?
When we talk about big data, they talk about volume and veracity and all these V's. And I suppose it's not just about the size. It is other things as well. The variety is one of the key things in big data.
Okay.
The variety, and that's where the unstructured comes from. So we're not sure what it is. So those data sets you described are actually structured data.
Okay.
And you can do what you talked about, where you might want to discover something new from those two data sets. That's data mining. And data mining is conducted on structured data. Okay, so it is quite different. Ultimately, businesses want to make decisions on facts so that they make the correct decision. That's what data is all about now. Businesses making the right decision, whether it's to produce a new product, to market it in a particular way, to provide a service, to improve a service. Whatever their decision making is, they want it supported by data, whether it's structured, which businesses generate all of the time. Businesses since the year dot have structured data. They store it. It used to be in filing cabinets. Now it's in databases. When we add big data to that, it adds another layer of information or context. So we add the chat on social media about their business or their new product.
Yes.
We add demographic information or sensor information about temperature. We add other pieces of data that may exist in big data, may exist in structured, but they're external sources that the business purchases or has access to.
So can I give you an example to this now? That
Sure.
Please tell me if I'm wrong, because I could easily be. I'm wrong about lots of things in my life. So I use Google Maps for navigation in the car if I'm driving somewhere. Kind of usually, say if I'm driving to Dublin, because I don't know Dublin particularly well. I find driving in Dublin City a nightmare because I can't
Stressful.
you can't turn right anywhere. So use Google Maps, and if the thing that you can see it in the car screen and all that, and occasionally what it will do is you will show you a road up ahead, and it will put a colour on it, which could be kind of orange or red, and then it might say actually you should go another way. And I read up a little bit about this, and it says that actually what it's doing is it's reading what speed you and other drivers should be going on that stretch of road. And if you're going much slower, it would indicate that there's either an obstacle, it could just be a kind of traffic jam, or it could be there's an accident and things have stopped. And then what it's doing is it's feeding back that information which is being collected from people's phones and cars and etc., watches and whatever wearables you're having, back into the Google Maps navigation engine and feeding that back in real time to me. Is that what you're talking about?
Yes.
Okay.
Hey.
Okay.
Yeah, that's a great example because it incorporates both, the kind of structured data within the car and knowing what speed you're going at and how much fuel there is and so on, with external data, which is available through whether it's AA Roadwatch or what other traffic management systems. Perhaps it's traffic light systems they're able to tap into.
Yes,
and so on. The possibilities are endless, and it's basically doing real-time analytics. And that's what the self-driving cars do all of the time, analysing the current data right there at that moment and making a suggestion to you. So it's suggesting an alternative route. So that's real-time or right-time analytics.
Now, that I can see the benefits of something like that. And I can't really see anyone complaining about better traffic management. Well, unless somebody's a complete crank. They are out there. But, by and large, I think most people would agree that that's probably of benefit to society. Go for it.
Except there are circumstances. So I know in America, they're using different apps to us sometimes.
Yes.
I can't remember, of course, the name of it at the moment, but
there's Waze is a very popular one.
Yeah, it could have been that one. And more people were using it, and it would suggest alternative routes. And then it worked out that there was a particular residential neighbourhood that was used as an alternative route. Kids, school, and so on.
Yes.
And that that disrupted people's lives. So yes, it is great, but then there are some circumstances where unusual things happen.
Well, that's great, because that's actually what I was going to bring on to, is the world of unintended consequences and possible ethical dilemmas that might be out there. I don't know if either of you want to take this. Go for it, Siobhan or Brenda. By and large, everything looks rosy, or you can imagine it's rosy, or you could say if you're able to deliver better healthcare or better, but so much more could be there. Not necessarily outright evil, and I'm using evil in quotes, saying I want to do bad things with this data, but I might end up doing things unintentionally.
Absolutely, yes.
Yeah.
And I suppose it comes back to the era we now live in, the devices we use. And so, it comes back to us in education. It's very important to teach our students how to ethically, morally store data, because a lot of what I teach in the early years is designing good databases. So you have to consider things like the data protection laws and now GDPR. And so there are our oversight to ensure that we don't store data that we don't need. Now, the other side of that is we may need it, but then when we do analysis, we discover or we have unintentional circumstances or consequences. And, there are lots of examples of that. There's a classic one about Target in America.
Go for it. Yeah. I was going to bring this one up.
Yeah,
but
I can't remember. It's a few years ago now, so there are probably even better ones now. But Target in America, I can't remember what state it was in. One of the Midwest states, I think. And an analyst began to look at the data, and they wanted to discover. They wanted to be able to promote products to females in a certain age bracket in their first trimester of pregnancy. So they did analysis on the female data of their customers because, like here in Ireland, they have loyalty cards and so on. They gather a lot of data on purchases. So they discovered a pattern whereby certain products that were bought, something like body lotion,
it's unscented body lotion, and things like that.
Blankets. So very specific products, when they were bought together, that it was discovered that a large portion of those females were later revealed were pregnant. So they obviously tested their analysis, and they sent out a marketing flyer offering a discount on cot. And lo and behold, father knocks on the door of the manager, and his 16-year-old daughter had this flyer posted to her. And so obviously he was very cross. So in the jigs and the reels of it anyway, she was actually pregnant. They had accurately predicted based on purchases. But there's a good example of invasion of privacy. Ethically, is that appropriate to be marketing and targeting people in their first trimester and so on? There's lots of moral questions within there. They did decide that it was inappropriate.
Yeah, so a teenage pregnancy being revealed by a flyer coming in the door, as opposed to a more mature discussion, or whatever is going on between the people.
Further consequences of those who may have subsequently miscarried and so on.
Course,
there was many aspects to it, which they obviously realised and understood afterwards. But like that, having access to so much data and having also the capacity to analyse it how we do now, the things that we can discover in the data, the patterns that we can find, if we look hard enough and if we have enough data, are fascinating. An awful lot of them are not of value to a business, and that's ultimately what they want.
Does everything have to be of value? As in everything of monetary value to a business?
No. So data projects or business analytics projects, as you might call them, sometimes they're hard to put a value on because there isn't a monetary end game.
Yes.
It may be to improve customer satisfaction or to reduce the rate of time it takes to deal with a complaint. And you do analysis on your data to see where are the bottlenecks or what's causing these problems. So you discover in the data what's going on. And so you can't say that netted you a certain amount in revenue or lowered your cost by a particular amount. So it's not always about value. But if you look in the area, you read, it is very much about, is it valuable to the business? So not necessarily just financial.
Yeah. So do governments get involved in this? Do they? We don't know.
Yes,
they do.
Yes, they do. They try to, but
I mean, I'm thinking about the census. Surely the census is
so that's a classic.
Is the old form of big data, paper, blah 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 blah.
Yes, yeah. Again, it's structured data.
Yes.
We know exactly its format and so on. And it's very useful, and lots of businesses would use the census data in order to understand the customer base in Ireland and the demographics. So things like where people live, how they travel to work and so on, incomes and so on like that. And the census data is great because it's the whole population. So whatever you discover in that census data, you can say that it applies to the whole population of Ireland. Whereas if I go and survey just the students in my classroom, I can only say that I discovered that the students in my classroom all pass. But that only applies to my classroom. I can't say that applies to Siobhan's classroom or anybody else's classroom.
Yes. So earlier on, I said the kind of data science was possibly a kind of an intersection point with programming, mathematics, statistics, and analysis. Now, based on our discussion here, I'm now revising this, and I'm going to put this to you, Siobhan, that
Okay.
we also actually need to include probably a wider screen worldview, ethics, and something that I don't know if it can be taught, but cop on. How would you feel about that, Siobhan?
No, I think you're dead right, because ultimately it's a lot of the responsibility does fall with the programmers on what is really done with the data. And it's not just the programmers as well, it's also those who are doing the data science analysis as well. So you'd use different programming techniques to do that. So yeah, no, it definitely does fall with us to make sure that we are not violating ethical and even legal reasons. To do that, definitely.
I mean, it's quite staggering, really, when you think about it, that, you know, you kind of have to be part philosopher to be involved in this.
Sure. Yeah.
And
it's
it's only
far-reaching.
Yeah,
You
it
can
really
cause
is.
a lot of damage.
Yeah. It could also cause, it's a double-edged sword, because it could also cause a lot
of good as well.
A lot of good.
Yeah.
But,
Yeah, and particularly depending on the industry. I mean, lots of industries are regulated. And so if you're in the pharmaceutical industry, the finance industry, the healthcare industry, there's very strict rules about what data you store. There must be audit trails. So if any piece of data gets changed, there must be a trace of who changed it, when they changed it, what it was, what it is now.
Yeah.
Things like that. So there is oversight from a legal perspective within many industries, but the moral or ethical side of things obviously isn't necessarily covered in there. Or privacy, you know, private.
Well, but this is where we've had a lot of headlines
Yes.
over the last number of years, largely to do with social media companies, not just social media companies, but largely social media companies, big data breaches. Sony had a massive data breach a couple of years ago on the PlayStation platform. We've had the Cambridge Analytica scandal with Facebook, another recent data breach with Facebook.
That's right.
You know, and they're not regulated.
No.
But they have a huge amount of personal data directly given and also inferred through other items.
Yes.
And that's kind of scary.
It is. I think I was only just recently reading 2017 was considered, you know, a really bad year for data because there were so many breaches, and particularly Facebook.
Yes.
And what it has done is it has highlighted the need for responsibility. And when we talk about social media or any of those companies that are not traditional finance and so on, that are not regulated, but they have to have some social responsibility about the data that they collect. That's important, and that's what's emerged out of this, and them recognising that they need to have that there are consequences to them allowing people to post anything at all and so on, particularly, you know, the younger age group and that. But there isn't direct regulations apart from now, I suppose, GDPR within Europe. But it's much harder to regulate those organisations and that type of data as well, because it's all built on peer-to-peer, or it's all built on, it only exists through people using it, through me and you posting on there. And so how do you regulate that? And then I suppose it's to ensure that Facebook and Snapchat and WhatsApp and all these other companies protect the data. Not that they can't prevent breaches outright. They're going to happen. That's a reality. But they have to be able to react to it, prepare for it, have a plan in place. It's more the reaction to when it happens. We usually learn about it at least a year later.
Yeah.
You know, in many cases, it's been 2 or 3 years later. Huge breaches.
Yeah.
And there hasn't been sufficient communication about it. So it's more their reaction and how they deal with it afterwards, because they are going to continue to happen.
Yeah. I think this is maybe an area that we'll come back to in a whole other podcast, because we're only scratching the surface of that now, and there's a whole other kettle of fish there. I want to finish on one thing, because we've talked about data analysis, and I did some sums before we came in, and big data, because I just tried to quantify it. And you gave some figures earlier on, Siobhan, about the amount of data in the thing, and I found a quote from Eric Schmidt, the CEO of Google, who knows a thing or two about data, and he made a statement that if we thought of all the data created by humans from the dawn of civilization up until 2003, and we thought of that about a unit of data, that same unit of data is being generated by humans every 2 days, and it's accelerating. So that would be kind of similar to what you said. And then I kind of thought about, well, what is this data? And then I looked up, heard another analogy done on another podcast I was listening to, and I thought about Greek numbers. Okay, so we talk about data, we talk about a byte. So a byte is 8 bits, and that's kind of usually one character, one ASCII character, which would be like one letter or number. A kilobyte is 1,000 bytes, or actually it's 1,024, but we'll just say 1,000 for the sake of argument, okay? A megabyte is 1,000 kilobytes, so that's 1,000,000 bytes, 1,000,000 characters. A gigabyte is 1,000 megabytes. A terabyte is 1,000 gigabytes. A petabyte is 1,000 terabytes, and an exabyte is 1,000 petabytes. And an exabyte is 1,000,000 million bytes, okay? Or a petabyte is 1,000 million bytes. Now, if we thought about plain text and we think about data processing, a human being reads about 200 to 250 words per minute. Okay, and on a page, like if I had a plain text page, each character being 1 byte, you fit around about 2,500 to 3,000 characters on a page, and it's usually around about 500 words, okay, ish. So if we have 2,500 to 3,000 characters, let's say it's between 2.5 and 3 kilobytes, and it would take a human being roughly 2 minutes to read a page. Okay, roughly ish. And again, if we just go back down, that basically means a human can read about 1 kilobyte a minute. It would take a human about 17 hours to read a megabyte of text. That's reading flat out. And it would take a human over 1,000,000 years to read a petabyte of data. One human, 1,000,000 years.
There you go.
And that's been generated every fraction of a second. It's kind of scary.
It is. It's crazy. Crazy amount of data. And what I find crazier is it's not really destroyed at any point. Yeah. In certain regulated areas, it is that you dispose of it after a certain time. And depending on your jurisdiction, that's governed in different ways and different time frames. But you don't often hear of businesses deleting their information. And so where is it all stored? And how can you protect all of that data? And ultimately, we're creating more and more data. We're doing more and more analysis on it. But we're not understanding it anymore. Hasn't that scale hasn't gone up that much. So we're getting more and more of it, but we still only understand about 20% of our data.
So that's perhaps the next frontier. Don't say the final frontier, but it's the next maybe frontier is deeper understanding of these things. And that leads us into a whole other areas of machine learning and all that, which we might cover in another podcast. So a lot of the data, though, that we have out there is completely useless. I mean, it's rubbish. It's insane blog ramblings, comments, social media nonsense, cat videos. It's whatever. It's also memes. This podcast. It's this podcast. This podcast is going to contribute a certain number of megabytes to the data pile, and that'll be duplicated and replicated. And maybe you might duplicate and replicate it as well. And tell your friends to listen to this podcast. Leave us a good review, and I think we leave it there. So to Brenda Mullally and Siobhan Drohan, thanks for talking about data. I think we have to come back to this topic. We've introduced a lot of topics in here, and I think it's a fertile ground for some analysis. You can use that one. Lads, thank you so much.
Thank you, Rob.
Thank you.